This is for Year 12 methods. It comes out of Chapter 11. It's 11I, question number 9. Now the reason that this question is asking me to find the inverse and then to find the area to do with the inverse and then use that to find the area under the function is that this area here from 1/2 to 2 of log base e of 2x dx, which is what the question's asking me to do. I can't take the integral of a logarithm. What this would look like would be, that goes through there at 1/2, and if that's 2, this is the area I'm looking for. And I can't find that area. I mathematically can't take the integral of a logarithm. Now, this comes out of our class notes when we were in chapters H, I and J, and it's called turning the integration sideways or integrating the inverse. And that if I was looking for this area here, the area underneath this logarithm, I can't actually do it. So what I do instead is I'm looking for A, but I can't find A. So I look for the inverse. This is the inverse. I can use some mathematics to find B, and then from the rectangle, which is this large rectangle, once I know B, I can find A by minusing it from the large rectangle. So I take the inverse, I integrate the inverse, and then I look for similar regions, similar areas. Okay, so let's see what's happening here. I'm asked to find the inverse. Okay, so if y equals log base e of 2x, and if I swap them to find the inverse, x will equal log base 2e of 2y, turn it into an exponential, 2y equals e to the x, y equals 1/2 e to the x. So the question's asked me to find the inverse, and the inverse of x equals 1/2 e to the x. And if I was to draw the inverse, it's going to look like this, where that is 1/2. And if I was to consider the point which was log base e of 4, then subbing in I equal 1/2 e to the log base e of 4. E raised to the power of log base e of 4 will equal 4. That's 1/2 times 4, which is 2. So, if this is f of x, and this is the inverse of x, this area here that I'm looking for is the same as this area here. I go from 1/2 to 2, I go from 1/2 to 2. This curve and this curve has been reflected over the line y equals x. It's the inverse. So the mathematics of what's going to happen here is I'm going to use my integration to find this area, and that area there will be the integral from 0 to log base e of 4 of the inverse of x dx, and that will give me the green. I will then find out this because this is that same green area, and I can do a rectangle and do a substitution of a rectangle. Okay, so I need a little bit more space. Part B asks me to find the exact area of the inverse from 0 to log base e of 4, and that will be this green area. Shouldn't do it in green, should I? Shouldn't do it in blue. So that's that green area. And that's going to equal the integral from 0 to log base e of 4 of 1/2 e to the x dx, which equals 1/2 e to the x from 0 to log base e of 4, which is 1/2 e to the log base e of 4 minus 1/2 e to 0, which equals 1/2 times 4 minus 1/2, 2 minus 1/2, 3 on 2 is going to be what that equals. That's part B. Part C then asks, find the exact value of 1/2 to 2 of f of x dx. and that's this area here. So let's say I call this A and I call this B, and I know B equals 3 on 2 because I calculated that over here. I know that A plus B will equal the rectangle, which is width of 2 times the height of log base E of 4. So it's going to be 2 log base E of 4, which is 2 log base E of 2 squared, and the 2 from the front can come down and give 4 log base E of 2. So that's what A plus B equals. I'm interested in what A equals, and A is going to equal 4 log base E of 2 minus B, and B is 3 on 2. I know it's not square units because it just said the exact value. So that's going to be my answer. 4 log base E of 2 minus 3 on 2. And that's using the idea that if I take the inverse of something I can't integrate, then this area A becomes that area A, this area B becomes this area here, and I can find out B by using the inverse and taking the integral of the inverse. And then I use the rectangle idea to find out total.